Hey everyone, Mr. Maz here, and my good friend Cooper. He is going to star in part of our video, him and his friends. Cooper is our little puppy, he's a little over a year old. We also have an old man pug, Willie, he's almost 14, and our neighbors got a new dog named Charlie. Yesterday it was nice out, and these dogs like to chase each other around the yard for some exercise, and I, of course, always think math. And I thought of, well, I can use this to come up with some linear equations to show my algebra students. So that's just what we did here. Here's a short clip of what you were talking about. And I get a still shot here to get an initial starting point. If we look at the white line as where they're going to start, you see Cooper has obviously the biggest advantage right now. Charlie is in the middle, and Willie is at the beginning. Then I had to add a stopwatch to this so I could figure out some speeds and get some data that we could use for the math. So what we have here is an initial starting point for Cooper. If we're looking kind of at the rear of each of the dogs, Cooper is about 7 feet in front of the white line, which we're going to kind of call the starting line here. And when they disappear behind the house, it's about that distance is 14 feet. It took Cooper 0.6 seconds to hide behind the house there. It took Charlie 0.8 seconds to get to that 14-foot line, and he started about 3 feet ahead of that line. And then there's Willie at the back. He's starting right at that line, and it took him 2.1 seconds to get there. So using this information, it's kind of nice because we have a y-intercept. We have an initial value where x equals 0. Cooper's is 7, Charlie's is 3, and Willie's is 0. So the next thing that we would have to do here is find the slope. All right, and the reason that we want to do that is to find the equation of this line in slope-intercept form in y equals mx plus b. So as we all know, y equals mx plus b, m is the slope, that's the part that we're missing here, and b is the y-intercept, and we already have that. So looking at Cooper's, we have this equation, y2 minus y1 equals x2 minus x1. So for Cooper, we're going to take 14 minus 7, and those come from the y's, and then we're going to have 0.6 minus 0. So that gives us 7 over 6, or 7 over 0.6, sorry. And when we calculate that out, it's about 11.6 repeating. So we're just going to round that to 11.7. For Charlie, once again, we're looking at just the y's. And it's important to point out here, in y2 minus y1, if we use y2 first, if we use the 14 for the first y coordinate and the 3 for the second y coordinate, we have to use the 0.8 for the first x coordinate as well. And then we have to use the 0 for the second x coordinate. So the order that we subtract them definitely matters. So whatever order we subtract the y's in, we have to subtract the x's the same way. So here we get 11 over 0.8, and that ends up being 13.75. So now we're going to move on to Willie. Just simply going from 14 to 0, we know that that is 14, and 2.1 minus 0 is 2.1, and that gives us 6.6 repeating, so we're going to go ahead and round that up to 6.7. So that gave us the slopes of everything, so we can go ahead and put that into y equals mx plus b. So going to Cooper, we have y equals 11.7x plus 7. For Charlie, y equals 13.75x plus 3. And for Willie, y equals 6.7x. There is no y-intercept here, so we don't have to include it. Now we can use these equations to come up with a lot of things to compare them. First of all, comparing their speeds. Charlie is the fastest. His rate of change is 13.75, so he's traveling 13.75 feet per second. Cooper is the next fastest at 11.7 feet per second, and Willie is the slowest, only traveling 6.7 feet per second. And this is the beauty of math, is we're going to use this information to make some predictions. So Cooper clearly has a head start, but Charlie is a little bit faster, so we can find the exact point where Charlie is going to catch up with Cooper. We can also figure out exactly where these dogs are going to be after 1 second, 2 seconds, 5 seconds, 10 seconds using this. And that's the power of being able to model situations using math. Now, obviously, we are assuming a lot of things here. Since we assigned a linear equation to these, we are assuming that these dogs are going to keep a constant speed and go in a straight line, which obviously is not going to happen. They're going to make turns, they're going to slow down, they're going to speed up. But it is a starting point of how we can apply linear equations. The dog example was nice because they gave us the y-intercept, so we were able to determine the y-intercepts. But not every problem is going to be that nice. If we look at this graph right here, we just have 2 points. They don't give us a slope, they don't give us the y-intercept, so we have to be able to find the equation between 2 points. And we're going to go ahead and do that in y equals mx plus b, or slope-intercept form. And there is a process to that. So when we're looking at this, this y-intercept is right in between 2 numbers. We can't tell exactly what it is. It might be negative 2.5, but we're not sure. It could be negative 2.4. It could be negative 2.49. We're not exactly sure. So we have to use our math to figure that out precisely. The first step in finding the equation of a line between 2 given points here is finding the slope. And we have that formula, y equals y2 minus y1 over x2 minus x1. So looking at our points, we have 6, 2 starting up here in the first quadrant and going down to the third quadrant, we have negative 2, negative 4. So as mentioned before, we have to put these into our formula, and using the y's, I know the equation says take y2 first, but it really doesn't matter. I could have said let's start with the point in quadrant 3 if I wanted to. My personal preference is let's try to get a positive number, so I use the greater y. So when I'm looking at 2 and negative 4, I'm going to use 2 first because it's bigger than negative 4, and then we keep in mind that we have to subtract the x's in the same way. So we'd use 6 first since we used the 2 first for the y. So we go ahead and subtract 2 minus negative 4, and we take 6 minus negative 2. And keeping in mind here, when we subtract negatives, it's really just like adding. So 2 minus negative 4 is really 2 plus 4. So that gives us 6. And then 6 minus negative 2 is 6 plus 2, gives us 8. And that'll simplify to 3/4 here. Now that's if we were just given the coordinates, but obviously we can look at a graph and look at the rise over run as well. So between these 2 points, the rise, which coordinates with the difference of the y's, is 6, and the run is 8. And that would simplify to 3/4. So that's a different way that we could find the slope if we were given the graph. If we were just given the coordinates, we would have to use the formula. So we've determined what the slope is, so we know what m is, and in slope-intercept form, there's an m and a b that we have to figure out. That's why they call it slope-intercept form. So step 1 was to find the slope. Step 2 is to find the y-intercept. So we know in all of these equations, we need, or y and x represent a point. So we'll go ahead and take this point 6, 2, and we're going to substitute that in for the x and y. So 6 would be our x, 2 is our y. We already know that our slope is 3/4, so we can substitute those into y equals mx plus b to figure out what b is. So we're going to put 2 in for y, 3/4 in for the m, 6 in for the x, and we're going to solve for b just using some algebra here. So 3/4 times 6, I know that 4 and 6 have a common factor of 2, so I'm going to go ahead and simplify that so we can multiply our fractions, just multiply the numerators here. So we get 9 over 2 here. So our equation turns into 2 equals 9 over 2 plus b. So to solve for b, all we have to do is subtract 9/2 on both sides. And to subtract fractions, we need common denominators. So I'm going to go ahead and change 2 into 4 over 2. Now you could use a calculator if you wanted to that has fraction capabilities. So 4 over 2 minus 9 over 2 gives us negative 5 over 2. So that's going to be our y-intercept. And so our last now that we have identified get the equation our slope is very simple. We're just going to substitute and this our y-intercept of negative 5/2. We can write our equation. Out that m is so 3/4. Y equals so we have 3/4 x minus 5/2. And once again, we don't need to put plus a negative 5/2. That is just the same thing as saying negative 5/2 or minus 5/2 at this point. Is negative 5/2. Now, you will see some problems on your ALEKS assignment this week called linear equation from 2 points. Some of them will give you the slope and you'll have to find the y-intercept given a point. Some of them will give you 2 points like we just did. Some of them will give you a point and a slope. But it's basically all just figuring out what you can put in for y equals mx plus b. But the most difficult problems are going to be what we just did. If you have 2 points, you find the slope, and then you find the y-intercept. This week, we're going to get back into Study Island on Thursday, and that is going to have all of the linear stuff that we have been talking about. What are the different forms, how to find slope from 2 points, how to find the slope-intercept form from a graph, what's standard form, what's point-slope form, all of that is going to be involved. So after you complete this assignment, I would go back and start reviewing what you've done in the past. You can go back and rewatch the YouTube videos, do some review on ALEKS. You can even go back and retake those assignments, or you can even practice on Study Island. Remember, you have unlimited attempts to do that. Once again, if you need me, I'll be in my Zoom sessions at our scheduled time and during office hours, both Monday and Tuesday for this. And then when you get to the Study Island, I'll be there Thursday and Friday as well.